Euclid division lemma.
Subscribe the channel and press the bell icon to get latest updates from LearnFatafat.com.
For any two positive integer a and b, there exist unique integers q and r satisfying a equal to b multiplied by q plus r.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Where a and b are any positive integers from 1 to n, q is quotient, r is remainder, and t is product of b and q. Let's understand this by solving a simple puzzle. A basket is full of bananas, but we don't know exactly how much bananas are present in the basket. Basket can accommodate bananas less than 150. Let A is total number of bananas basket have, which is less than 150. We only know that if bananas are counted in pairs, one will remain. So, by applying Euclid's division lemma, we get A is equal to 2 into m plus 1. If bananas are counted in 3, 2 will remain. So, we get A is equal to 3 into n plus 2. If bananas are counted in 4, 3 will remain. So, we get A is equal to 4 into O plus 3.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
If bananas are counted in 5, 4 will remain. So we get A is equal to 5 into P plus 4. If bananas are counted in 6, 5 will remain. So we get A is equal to 6 into Q plus 5. If bananas are counted in 7, 0 will remain. So we get A is equal to 7 into R plus 0. Step 1. Now, from last equation, 0 bananas will remain. That means A is divisible by 7. So now, we consider numbers less than 7. That is 2, 3, 4, 5 and 6. If A is divided by 2, 3, 4, 5 or 6, the remainder is 1, less than the divisor. Therefore, A is 1, less than LCM of 2, 3, 4, 5 and 6, or multiple of LCM of 2, 3, 4, 5 and 6 minus 1.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Now, LCM of 2, 3, 4, 5 and 6 is equal to 60. Therefore, by trial and error method, A can be 60 minus 1, 120 minus 1 or 180 minus 1. Step 2. Now consider 60 minus 1, 120 minus 1 and 180 minus 1. Therefore, 60 minus 1 is 59, which is not divisible by 7. Similarly, 120 minus 1 is 119, which is divisible by 7. Therefore, A can be 119. Step 3. From given condition, A is less than 150 bananas. Therefore, 180 minus 1 is 179. So, that much bananas are not available. Therefore, total number of bananas will be 119. Puzzle solved. Basket have 119 bananas. Euclid division algorithm.
Subscribe the channel and press the bell icon to get latest updates from LearnFatafat.com.
It is the algorithm used to calculate the highest common factor, HCF, of two positive integers, A and B. Let's take an example. Once, John was trying to calculate the HCF of two numbers, 12,576 and 4,052.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
How it can be done? It is so confusing. Searched all the books, but it's really tough. I'm not getting the answer. It's frustrating.
Hi John, what happened? Any problem?
Hi Sean. Yes buddy, I'm stuck in this HCF problem. Can you help me in that?
Yeah, why not? I have an idea to calculate this easily. Just follow these steps.
Step 1 is to apply Euclid division lemma to 12,576 and 4,052. That is, 12,576 is equal to 4,052 multiplied by 3 plus 420, where 420 is remainder of these two numbers.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Step 2. Here R, that is 420, is not equal to 0. Apply lemma division to 4052 and 420. Step 3. Here R, that is 272, is not equal to 0. Apply lemma division to 420 and 272. Continue the process till R, that is remainder, is equal to 0. Similarly, check for R, that is 148, is not equal to 0. Apply lemma division to 272 and 148. Now, check for R, that is 124, is not equal to 0. Apply lemma division to 148 and 124. Now, check for R, that is 24, is not equal to 0. Apply lemma division to 124 and 24. Now, for R, that is 4 is not equal to 0. Apply lemma division to 24 and 4. Here, R is equal to 0. Therefore, HCF of 12,576 and 4,052 is equal to divisor at this stage.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Therefore, HCF of 12,576 and 4,052 is equal to 4. These are the steps to apply this Euclid's division algorithm in finding HCF of two positive integers, a and b. The fundamental theorem of arithmetic.
Subscribe the channel and press the bell icon to get latest updates from LearnFatafat.com.
For example, calculate factors of 12. 12 can be factorized as 2 into 6. Then again, 6 is simplified as 2 into 3. That is, 12 is equal to 2 into 2 into 3, where 2 and 3 are prime numbers and 12 is composite number.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Therefore, 12 can be factorized as 2 square into 3. Hence, we can say that composite number is factorized as product of primes. Let us consider another example. Calculate factors of 60. 60 can be factorized as 2 into 30. Then again, 30 is simplified as 2 into 15. That is, 60 is equal to 2 into 2 into 15. Then again, 15 is simplified as 3 into 5. That is, 60 is equal to 2 into 2 into 3 into 5. In this example, 2, 3, 5 are prime numbers and 60 is composite number. 60 is factorized as 2 square into 3 into 5. That is, product of powers of primes. Both 12 and 60 are factorized by same method. So we can say that any composite number x can be factorized as x is equal to p1, p2, p3 till pn, where p1, p2, p3 till pn are primes.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
And written in ascending order as P1 is less than equal to P2 is less than equal to P3 till Pn. The fundamental theorem of arithmetic stated as the prime factorization of a natural number is unique except for the order of its factors. That means every composite number can be written as the product of powers of primes. Let's take some example. First, in this, we have to calculate the value of n, where 4 raised to power n ends with digit 0. If last digit of 4 raised to n is 0, then 4 raised to n has to be divisible by 5, and the factors of 4 raised to power n would contain the prime 5. 4 raised to power n, it can be written as 2 raised to power 2 into n.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
As per fundamental theorem of arithmetic, there is unique factorization of 4. Therefore, 4 raised to power n is not divisible by 5 and will never end with digit 0. Another example where we have to find HCF and LCM of 6, 72 and 120 using the prime factorization method. Let's factorize 6, 72 and 120. 6 can be factorized as 2 into 3. 72 can be factorized as 2 into 36. By simplifying 36, we get factors of 72 as 2 cube and 3 square. Now, 120 can be factorized as 2 into 60. Then, by simplifying 60, we get factors of 120 as 2 cube into 3 into 5.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Factors of 6, 72 and 120. Therefore, HCF of these numbers are 2 into 3, that is 6, and LCM of these numbers are 2 cube into 3 square into 5, which is equal to 360. Theorem 1.3.
Subscribe the channel and press the bell icon to get latest updates from LearnFatafat.com.
Stated as, let P be a prime number. If P divides A square, then P divides A, where A is a positive integer.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Proof. Let the prime factorization of A is equal to P1 into P2 into P3 till Pn, where P1, P2, P3 till Pn are primes. Therefore, A square is equal to P1 square into P2 square into P3 square till Pn square. It is given that P divides A square. Therefore, from fundamental theorem of arithmetic, it follows that P is one of the prime factors of A square. We realize that the only prime factors of A square is P1, P2, P3 till Pn. So P is one of P1, P2, P3 till Pn. Now, since A is equal to P1 into P2 into P3 till Pn, that is, P divides A, hence the theorem is proved. Theorem 1.4. Root 2 is irrational. Proof. Let us assume to the contrary that root 2 is rational. So, we can find integers r and s, where s is not equal to 0, such that root 2 is equal to r by s. Now, suppose r and s have a common factor other than 1.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
Then we divide by the common factor to get root 2 is equal to a by b, where a and b are co-prime. So b into root 2 is equal to a. Squaring on both sides and rearranging, we get 2 into b square is equal to a square. Therefore, 2 divides a square. Now, by theorem 1.3, we can say that 2 divides a. So, we can write a is equal to 2c for some integer c. Now, we have a is equal to 2c and a square is equal to 2b square. By using this, we get 4c square is equal to 2b square. That is, b square is equal to 2c square. This means that 2 divides b square, and so 2 divides b by theorem 1.3. Therefore, a and b have at least 2 as a common factor. But this contradicts the fact that a and b have no common factors other than 1. This contradiction has arisen because of our incorrect assumption that root 2 is rational. So, we conclude that root 2 is irrational. Let's take an example in which we have to prove 3 root 2 is irrational. Let us assume to the contrary that 3 root 2 is rational.
Watch ad-free and complete syllabus on LearnFatafat Android app. Download the app now.
That is, we can find co-prime a and b, where b is not equal to 0, such that 3 root 2 is equal to a by b. Rearranging, we get root 2 is equal to a by 3b. Since 3, a and b are integers, a by 3b is rational, and so root 2 is rational. But by theorem 1.4, root 2 is irrational. So we conclude that 3 root 2 is irrational.